Welcome, developers. Today, we are exploring one of the most powerful architectural patterns in Claude Code, subagents. We will learn how to orchestrate child agents to handle complex, long-horizon tasks while your main agent manages the high-level architecture. Let's get started. Welcome, developers. Today, we are diving into one of the most powerful architectural patterns in Claude Code, subagents. Think of the main Claude agent as your lead architect and subagents as specialized child workers. This hierarchical delegation mirrors real-world software teams. When a task is too broad, the main agent delegates it to a specialist equipped with the exact tools needed. Subagents operate in their own context windows, keeping the main conversation perfectly clean and preventing the AI from getting confused by too much competing information. This flowchart illustrates the hierarchical delegation pattern. At the top, the main Claude agent manages the overall goal. Instead of executing everything itself, it delegates specific tasks downward. On the left, it spawns a code reviewer subagent, and on the right, a data researcher subagent. Crucially, each of these child agents operates within its own isolated context window, preventing information cross-contamination. Why do we need this complexity? The answer is context isolation. If your main agent reads a massive log file, your context window becomes polluted with noise, which degrades the AI's performance. With subagents, the main agent generates a prompt, sends it to the subagent, and steps back. The subagent does the heavy lifting in isolation and returns only a condensed summary. Furthermore, you can apply the principle of least privilege by restricting what tools a subagent can access, ensuring a code reviewer agent cannot accidentally modify production files. Let's look at the context flow in this sequence diagram. The main agent initiates the sequence by sending a targeted task prompt to the subagent. Notice the loop in the middle. The subagent uses tools and reasons through the problem entirely on its own. These intermediate steps remain hidden. Finally, the subagent returns a clean, condensed summary back to the main agent, preserving the main context window's token limits. Claude Code doesn't leave you empty-handed. It ships with built-in subagents like Explore, which uses the fast haiku model and read-only tools to quickly search your codebase. There's also a plan agent for gathering research safely before writing any code. But the real power lies in custom subagents. You can generate these interactively by simply running the /agents command in your terminal. This allows you to define specialized personas, like a rigorous security auditor, and route their tasks to specific, cost-effective models. This mind map breaks down the subagent ecosystem. Branching to the left, we have the built-in agents provided by Anthropic, Explore, Plan, and General Purpose. Branching to the right, we have custom agents. These can be scoped to a specific project to share with your team, scoped to your user profile for personal use across all repositories, or distributed globally via plugins. Let's look under the hood. A subagent is physically defined by a simple markdown file consisting of YAML front matter and a system prompt body. The most critical field you will write is the description. This is not just metadata, it is the exact text the main agent analyzes to decide whether to automatically delegate a task to this worker. Inside this front matter, you can strictly define tool access using the tools or disallowed tools fields. For instance, you can grant access to the read and grep tools, but explicitly deny the edit tool to enforce read-only behavior. This diagram dissects the anatomy of the subagent configuration file. The markdown file is split into two halves. The top half is the YAML front matter, which configures the name, description, tool allow lists, and model selection. The bottom half is the system prompt body, which dictates the actual behavioral instructions the AI model will follow during execution. So how do we actually spawn these child agents? There are three main escalation paths. First, natural language. You simply ask Claude to do a task, and it auto-delegates based on the subagent's description. Second, the explicit at mention. By typing the @ symbol and the agent's name in your prompt, you force Claude to route the task specifically to that worker, removing any guesswork. Third, you can run your entire session as a specific subagent using the --agent CLI flag. This overrides the default system prompt completely, putting you directly in conversation with the specialist. This state diagram explores the three invocation pathways. Starting from the user prompt, the system can take the auto-delegate route relying on natural language matching, the explicit route utilizing the @mention syntax, or the session override route configured at launch via the CLI flag. Regardless of the path chosen, all three converge successfully into subagent execution. Execution modes are critical for workflow efficiency. Subagents can run in the foreground, which blocks your main conversation until the task finishes. However, they can also run in the background concurrently. This allows you to keep working while the AI handles a massive refactor. When spawning a background agent, Claude Code will cleverly ask you for any required tool permissions up front. Once approved, the agent works silently. If it hits a snag that requires human clarification, that specific tool call fails, but the agent keeps going, ensuring your local terminal isn't unexpectedly hijacked while you are typing. Here we compare the execution modes. Upon a spawn request, the system checks the execution mode. If foreground is selected, it blocks the terminal and awaits completion. If background is selected, it immediately requests all necessary tool permissions up front, runs the process concurrently, and safely allows the user to keep typing in the main thread. Let's explore a real-world use case, isolating high-volume operations. Imagine you need to parse massive log files or run comprehensive, verbose test suites. Doing this in the main thread consumes massive tokens and pollutes your history. Instead, you spawn a subagent. The subagent churns through the data in complete isolation and returns only the 3 lines of actual errors back to your main agent. You can even run parallel research by spawning multiple subagents simultaneously to investigate different parts of your codebase. This workflow massively scales your engineering effort without breaking your context limits. This sequence diagram maps out the high-volume use case. The developer asks the main agent to find an error. The main agent delegates this to the log analyzer subagent. The crucial step is in the middle. The subagent ingests 50,000 lines of text in total isolation. It then returns just 3 lines of errors to the main agent, which uses that clean data to synthesize the final bug fix for the developer. Let's conclude with best practices. Design focused subagents that excel at one specific task, write highly detailed descriptions, and strictly limit their tool access for security. Also, understand that subagent sessions are resilient. Their transcripts persist independently of your main conversation. If a subagent stops prematurely, you can simply ask Claude to resume it, and it will pick up right where it left off with its full history intact. Master subagents, and you master agentic architecture. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you there. Our final mind map summarizes subagent mastery. On the left, best practices dictates focus tasks, limited tools, and detailed descriptions. On the right, resilience reminds us that subagents have independent transcripts, survive main thread compaction, and feature resumable histories. Mastering these pillars leads directly to success, accelerated by visiting quicktechie.com.